In this question, we're asked to do an operation count for a 4x4 matrix that is doing Gaussian elimination. So let's assume that this is a 4x4 matrix with solutions at the end, right? So we've got A11, A12, A13, A14. This is going to be B1. And we probably don't need to write all of this matrix out. I'm going to do it just because, but I think we'll get the idea after we see one row done. This operation count also is going to assume that we have no issues with division by 0. Obviously, if there's a 0 in the pivot column, that's going to lead to some problems. And so we're just going to wish that away for the time being. So the first thing that we're going to need to do is we're going to need to pivot in column 1, and we pivot around the A11. So the first thing that's involved here is we take row 1 and we divide by A11. So doing that means we need 1, 2, 3, 4, 5, really 4, because we know that that's going to be a 1. That's 4 divisions. So that's 4 operations. Okay. Now, once we've done that, this is going to be a 1. These other things are going to be different from what they were. We can mark them with a little prime sign, right? So A12 is the old A12 divided by A11, right? So it's a different number, but it is just some number. Now, once this is 1, we have to get these guys to be 0. So for example, row 2 is going to be row 1 minus 1 over A21 row 2. Or it's going to be A21 times row 1 minus row 2, which is probably easier because you don't have any divide by 0 issues. In any event, you're going to have a subtraction and either a multiplication or a division. So you're going to have 2 operations, and you're going to have to do that 1, 2, 3, 4, 5 times for a total of 10 operations. It might be easier to leave that as 2 times 5 for the time being. Now you're going to have to do this for every row. So that's times 3 rows. So this is going to be done for row 2 and row 3 and row 4. So in total, this is going to be 3 times 5 times 2 total operations. Now the good news is once we're done that, this is now a 0, this is now a 0, this is now a 0, and we can move on to pivoting on A22. So if we rewrite this, we end up with 1, 0, 0, 0, and new versions of A12, A13, A14, and B1. New versions of A22, A23, A24, and B2. A32, A33, A34, and B3. A42, A4, 3, A4, 4, and B4. But now we have to do the same thing. We have to pivot around our A22 prime. So we're going to have to take row 2 and go 1 over A22 prime times row 2. That's going to be, if we include this, it's 4 operations. We might be able to get it down to 3 operations because we don't have to go around that. But for ease, let's just work with that for a minute. We're also then going to need to fix row 1, row 2, and row 3 and row 4. So same way we did it up here, we're going to need 3 times 5 times 2 operations. So for every column, we're going to need 4 operations to get our pivot 1, plus 3 times 5 times 2 operations to get the rest of our zeros. And we need to do this for every column. So we did it for column 1, 2, 3, 4. So we're going to end up having to do it 4 times. So our total here is going to be 4 times 4 plus 3 times 5 times 2. Okay. So once we do that, that gives us our total number of operations. Now, again, it's not quite this because we do it for the first one, and we can get away without doing it in the first column. So really that's a 3. This is a 4 here, so it does reduce a little bit. But we do have something that looks like 4 squared plus 4 times 4 minus 1 times 4 plus 1 times 2. Right? Because our 3 is going to change depending on how many other rows we have. Our 5 is going to change depending on how many other columns we have. And so in this case, we can figure out what it is. But in general, for an n by n matrix, we're looking at roughly n squared plus n times n minus 1 times n plus 1 times 2, which is of the order n cubed operations, which is not great. So anytime you have that many operations, you really want to try and avoid using any method that has a large n here. Okay, we want we would prefer this to be something more like log n rather than n.